Good morning, everyone. Welcome, everyone, to a new Cozumpark webinar. First of all, my voice may sound a little forked, friends. Don't play with your sound settings. It's all about my illness, unfortunately. Since last week, I'm dealing with an intense cough. I'm a little more recovered, but like I said, it's a lot like this. Probably I don't sound so good, therefore I apologize to all of you for the inconvenience. But today we have an important webinar, so I'm trying to keep my energy high in terms of motivation. Our first webinar with CosmoDot and Meti is with us. Welcome, Meti. Pleasure to have you. How are you? You look better than me, at least. That's great.
Hello, Hakan. Thank God I don't have any illness. I am just a little bit tired. It's just the busy schedule. I've been out of town and I got into town last night. I'm a little tired from that, but everything is fine.
Super. I'm happy for you. Our industry's chronic disease is being busy. There's nothing you can do about it. Yes, indeed.
It's happened.
Now, we're going to see the CosmoDot webinar, friends. It is a very good technology for us, and I was very excited when I first heard about it. You know, I have worked in the manufacturing sector. I have been in this sector. So even though I am now on the consultancy side of the table, I have been there for almost the last 10 years. And for the last 15 years, I have been on the customer side. And in fact, it was one of the issues that I was most obsessed with, both in terms of my past retail and manufacturing experience, even as a person who, after graduating from university, spent 4 years dealing with issues such as barcode, RFID, warehouse counting, tracking, etc. Friends talked about their inventions that attracted the attention of manufacturers all over the world. The invention they made is a special new generation code, tracks a part of its production to the warehouse stock, I don't know, the shelf. They said they make sure it is tracked up to the stores and beyond. I said, this is very difficult, friends. If it's a label, it wears out. I don't know, it heats up, it's processed, it melts, it disappears. Deformed when stored outside, for example, it is faded by the sun. I don't know, it's metal, you bend it, you twist it, you pull it, etc. I said, you know, like a lot of your stuff, after all, I'm an engineer, so I can't just come and say, let's talk about something like this. It's a very difficult thing to say if there really is such a thing. I said I would like to listen to this. In fact, it is such an important issue that when we first started our webinars, the people who are dealing with this business, that is the announcements, they showed a lot of interest. So this is actually a very motivating thing because today we will be talking about something that the industry needs. So imagine a technology as a label for a part you produce. I will roughly call it a label, but of course it is a digital label. In fact, there is artificial intelligence here. Meti will explain the details. So what is this industry standard that has passed through the well-known industry standard production process? It may be a thermal process, it may be heated, it may be expanded. The most well-known thing is that it may be painted. You paste the label or you mark the code on it, then you put a painting on it, and then you try to read it if you can read it. There are so many processes. And we have to go through all of that. And really for us, you know, technology is moving very fast in the world. After it came out, the Second World War, it's becoming incredibly digitized. And everybody's problem, what is the wastage rate of my machine? What is the ratio of parts in production? What is input and what is output? What is the production performance? This is how we call the industry 4.0 when we think about these things. Actually, it's kind of like this. I'm looking at the barcode. You know, you have a lot of products. You are counting by hand. And someone came and said, there is something called a barcode. You stick a label on it. Yes, then click. It gives you a count. I said, that's great, by the way. I'm saying this because I've experienced it at the age of 22. I said, that's good. When I was doing this, RFID came out. That's why I'm telling. We were counting a warehouse, 300,000 products. How do you count them? Assorted at most. There are 20 pairs of shoes, 30 t-shirts, and so on. That was the same period when they told me about RFID. Come on, I'm going to walk around in the terminal. It's just pop automatic. Now, Mete told me about it, and I said, this is good. I said, let's talk about a different solution. Now, I'll let Mete take the floor for a while. I know I told it in a very fairy tale epic way. I'll let Mete tell you a little bit about the technology part of this, and I'll leave the floor to Mete.
Okay, great. Thank you very much. First of all, I would like to thank all the participants for being with us in the webinar today. Hakan actually made a very nice introduction. As we are all seeing on the screen, we will be sharing the CDOT code today, the world's AI-compatible 2D code that CosmoDot introduced to the world, which is compatible with industrial artificial intelligence applications and can withstand all kinds of difficulties in industrial conditions. And I will actually try to explain how we intersect artificial intelligence with the product digitalization and traceability in our lives today, and how we eliminate all the problems here. Let me slowly start the presentation. And after that, I guess we will probably be moving forward with question and answer part. Okay, let's start then. First of all, CDOT code has actually brought traceability in the world today to a point where it can solve many areas where existing coding systems that we know currently may have problems. What do we mean? Especially in the existing coding technologies for many reasons. And we will be talking a little bit more in depth in the following slides. There might be some reading or writing problems. And reading and writing problems are the main fundamental problems that the industry has somehow tried to manage so far. But with batch tracking, with some internal methods, we actually try to close this. At this point, the CDOT code provides 100% reading on the object to which it is applied in the world today and in all phases, from the raw material to the finished product stage where that object can live. This has been modeled in a way that can cover all of the materials used in production processes in the world, which it has actually adapted to date. On the other hand, when we talk about industry, there are currently many difficult processes that make up the production of a car in our lives, the production of a washing machine, and there are actually difficult conditions and difficult challenges based on this. At this point, at a point where the need to bring artificial intelligence and industry together has come to an extreme, there is a fact that artificial intelligence, especially the artificial intelligence needed by the industry, needs to be born together with data. At this point, CDOT code has the ability to withstand these difficult conditions and connect the data it has created with process data and feed artificial intelligence. If we need to continue a little bit more, and when we start to dig into the details, we can actually see in the picture on the screen that CDOT code has emerged, especially in very difficult conditions. Basically, it would be right to gradually explain CDOT code as a concept under 4 headings. First of all, as I said earlier, there are a number of codes that we use for traceability. At the point of codes, we actually try to establish the link between the digital world and the real world. At this point, after realizing a 100% unique assignment, it has the feature of being applied to every part in the world. What do I mean? When you apply CDOT code on a surface, including elements other than what we describe as raw materials and finished products in our lives today, you can have the ability to trace the unique identity you have assigned to it and support artificial intelligence applications. When I say difficult processes, I will actually be going into more detail a little later. We are able to provide 100% reading in the difficult processes experienced by the entire industry in the world. Well, we have come up with a code. It is based on difficult processes. It reveals the one-to-one data feed to artificial intelligence. Have we developed a special specific device for this? Did we create a special machine to be used for printing? No, we did not. In fact, it is actually applicable to all printers used to print a code used by the industry on a surface in the world today. And we especially apply the laser marking technique in particular, because the conditions we talk about in the industry are very difficult conditions that can withstand these conditions. The most important application technique applied to ensure the continuation of these conditions is the laser marking technique. On the other hand, this code is the first of its kind in the world, and it is artificial intelligence compatible. Do you need a special camera, a special reader for this? No, it doesn't. We can read the CDOT code through all cameras, all handheld terminals, all smartphones in the world, and decode the identity we have assigned. To go into a little more detail. In fact, there are some technical details that I am sure all our participants are interested in, which they know from the codes they have used in the past. Today, we have a feature such as applying CDOT code on a surface in such a way that it can cover the entire surface from a minimum area of 5 square millimeters on a surface. At the same time, each code stores a data. It keeps a data in its own standard. At this point, we can store it in 32 alphanumeric characters of 192 bits, except for the data we associate. On the other side, the nuance that I tried to give examples to Hakan a little while ago is a very important detail. The codes that we assign on a surface usually lose their readability when faced with problems on any surface, when faced with blockages of the code assigned on the surface, so we cannot decode the identity that we have assigned. At this point, when CDOT code experiences 90% blockage, which can be up to 95% depending on the conditions and conditions, when you transfer CDOT code to the surface, it provides traceability without losing its identity, even if 95% of it is lost in the problems it may experience. On the other side, we actually know grades. Today's codes always have grades in practice. At this point, they have also classified those grades among themselves. In fact, with CDOT code, we can now put this grade concept aside, and CDOT code has a minimum readability of 99% when transferred on any surface today. And I say minimum, we are trying to underline it. While we were creating the code and transforming this code into a world launch, our main goal was that today, a product should complete its journey from end to end with the data it has without losing its identity. And during this journey, it should be able to feed data to artificial intelligence continuously. On the other hand, we talk about the structural changes of an object. These are requirements arising from the factors of production, which we encounter a lot in production. I will show the details and examples a little later. Even if the dimensions of the object double or triple, that is, if the structure of the object varies from 1 to 2 to 3 times due to the results of the process, CDOT code can continue on its way without losing its identity and assigned ID. To give some more striking examples, I just gave an example.
I'll go in, Meti, and I'll ask you the same question I asked you the first time. Mr. Omer from Q&A asked, I'm sure you will explain it on the engineering side as you explained it to me. I'm telling friends, I'm looking at the Q&A side. Question is exactly the same. I was thinking, if I paint it the same way, does it read? That's the question, by the way.
I was just getting there.
Minds think the same. When my friends were examining such a product, I said they'd paint it, blah, blah, blah. Now, those friends, I mean, of course, it's different from Mete. They said, how about if it is painted? You know, does CDOT code reads through it or something? He explained. Mr. Omer asked a very similar question about the painting challenge, and I'm looking at the Q&A. Mete will give you the details, Mr. Omer, for your information.
In fact, every product we talk about in production today starts from the raw material side. We have an example of a wheel, which we actually see on the screen. Now, when a car wheel, aluminum wheel or steel wheel is produced, when you actually assign any code before the object even takes its form in the first stage, as you just pointed out, when it is painted on it, we are talking about painting at a level of about 350 microns. When it is painted, when there is a code underneath that was previously assigned before painting, when it is covered with paint, it actually loses its identity. At this point, we are proud to say that this is actually one of CDOT code's most important capabilities. Even if it faces a paint coating of 700 microns, it can continue without losing its identity. Well, what does 700 microns actually mean? To give an example, I will say that the maximum paint thickness on the washing machines, refrigerators, and cars that we use in our homes today is the highest level. It does not exceed 300 microns. When we look at it from this perspective, when we place CDOT code before all the materials that are entering a paint process in our lives, we can ensure that they can be traced without losing their identity, even if they are subsequently painted. Another remarkable feature is heat treatment. What do we mean when we say heat treatment? Heat treatment is one of the most important processes in the industry today, affecting the strength structure of an object, affecting carbon values. At this point, an object is subjected to various degrees of heat treatment. One of the most important capabilities of CDOT code is that after transferring the identity of the object to CDOT code before it is subjected to heat treatment, it can ensure that the product continues without losing its identity, even if the product has undergone structural changes, even when it comes out of a very difficult process that can go up to 2 hours, 2.5 hours of heat treatment at 1,300 degrees. Another thing, we have just talked about it, is the affecting of surfaces. Generally, there are some processes that are applied on the surface, such as sandblasting and cataphoresis, which the industry knows very well. At this point, even if the surface experiences a 50 micron deformation, that is, the layer disappears on the surface, CDOT code can still continue tracking without losing its identity. Very small objects, very small areas, which sometimes produce a product in such a way that the industry naturally has problems with cameras trying to solve the problem of actually assigning an identity on the surface, where we are talking in millimeters. Advanced cameras are used for this. Efforts are made to analyze very small areas with various more specialized devices, which are often not stable. At this point, as I said at the beginning, when you place CDOT code on an area of 5 square millimeters, we can easily detect it with a normal standard camera in a robust and stable way. Another industry challenge is the factory environment and condition. Angles and distances are always critical factors. These are the factors that have so far prevented us from providing end-to-end item-level traceability. At this point, the maximum angles of 30 degrees, which you can imagine as looking at an object at very diagonal angles in our lives. Here, CDOT code is able to provide end-to-end item-level traceability under conditions such as 30-degree angles with a distance of 1.5 meters. Maybe it will be very simple, but light differences, light in factory environments today, spotlight differences, differences in the field, shadows, the effects of shadows on objects, CDOT code has actually removed the decoding problem of existing codes 100%. You can think of the other thing like an RFID feature. We can reach multiple CDOT codes on many objects at the same time through a single camera and analyze them at the same time. Finally, another thing that is actually remarkable is that the objects are also, they go through the steps, they go through acid, rusting, various products get dust or exposed to chemicals. That is, in fact, the object itself can be exposed to these, or the paper labels too. These, independent of the manufacturing processes, still impact item tracking. In all of these effects, CDOT code can provide 100% verification without losing its identity. Now I have tried to explain a little bit about the technical capabilities of CDOT code without getting too technical as much as possible. Now we need to talk a little bit about the link between artificial intelligence and CDOT code and the link between the object. So how can CDOT code achieve all this? What is our invention? And what did the relationship between this invention and artificial intelligence provide to each other? What have we added to the industry? Today, the world is actually trying to adapt and take a position on traceability 4.0 with the concept we call Industry 4.0, which we all know very well. And another adaptation behind this is actually artificial intelligence, the artificial intelligence of the industry. What do we actually mean when we say traceability 4.0? What are the process values of an object? As Mr. Hekan said at the very beginning, it is to be able to keep the process values assigned to it by the machine that produces it at the first stage when I start production, and the process data assigned to it by the other machine at each step, without losing its association with the product, and to monitor it end to end. Well, now we are talking about artificial intelligence, which is now in our lives and very fast in every point of the whole world. From the person on the street to every stakeholder of the industry trying to adapt quickly. So what does artificial intelligence need? As we all know very well, it needs data. If you cannot create the data, artificial intelligence will not be able to provide you with the modeled information and the fast processing capability that it can actually provide comfort. At this point, if we can transfer the process information assigned to the production of an object from the beginning to the end of the production of an object in real time into artificial intelligence models, we will actually connect artificial intelligence and industry end to end with 4 zeros of traceability today. At this point, if we go through a very short example, and in parallel, if we need to say what the hallmark of CDOT code is in the invention, you actually need to visualize this. First of all, in a very simple way, CDOT code is transferred onto the object in a laser marking technique. But what is the most important point? An initial phase. Then it goes into this very difficult process that I have just mentioned, which we will see together in the next slides. Reading without the use of a very special camera. And at the very moment when these steps take place, It has the ability to send the data we associate to artificial intelligence applications. So what is the main capability behind this invention? Today, unlike the codes we describe as normal, 2D codes, we have actually been able to adapt an invention point that the world has actually developed in different fields today, which is described as real-time signal processing and stenography, to 2D codes today. To put it a little more concretely again, we have actually combined the signal capability with the science of stenography and enabled C.dot code to emerge. This has enabled us to withstand all the difficult conditions and have all the technical capabilities that I have described from the very beginning. So what have we solved? What are we presenting to the world today? While we wanted C.dot code to take its position in the world as inventors, what was our main output? What did we focus on? What did we target? And what did we identify that actually led to the emergence of C.dot code? It seems that the industry has been producing many products in our lives for years, but almost 70% of the processes that exist in production today, both internally and in the supplier-OEM relationship, cannot be monitored end-to-end and associated with process data. Which industries are we talking about? Actually, we are talking about all industries, but especially aerospace, home appliance, automotive industry, especially low pressure, high pressure casting and casting industry based on this. Maybe we don't know that we don't see much in our lives, but in fact, for the production of a car or a sheet metal, there is an initial phase that starts with the steel that comes out of the mine, or the transformation of steel into billet and from billet to all the components available today. At this point, C.dot code, especially in these industries, as you can see on the right side, cataphoresis, sandblasting, structural variations of the surface, that is, expansion, elongation, and change of structural ratios with the effects of production on the surface. There are a number of types of coatings that we describe as metallized coatings, which are nickel, zinc, or multi-alloy coatings with certain factors, such as galvanized coating, zinc coating, heat treatment, and metallized coatings. All paint processes in the world, these paint processes are generally divided into many: electrostatic paint, wet paint. All these types of paint processes are managed without separating them from each other. And as I said at the beginning, only the digital identity assignment on the surface, as well as the products arising from the molds. C.dot code has become able to take its position in all of the very challenging processes, such as the birth of an object's design in a sand mold, then its combination with steel ore, its combination with iron ore, and then its transformation into a product. Well, it is necessary to go into detail a little more gradually. So we actually cover 70% of the world. As you can see on the screen, it has created a solution that can provide end-to-end readability of all 10 processes, which are absolutely in each production, but all of them, but sometimes with certain steps, with a minimum rate of 99%, and we are trying to quickly adapt it to the industry. To give very small scale examples, for example, let's say the number 8 you see below. In fact, the disc of a car is born from a sand mold. The drum is born. When we say those sand molds are molds, don't think of them as a single mold. In fact, they were born by the coming together of sand pieces that were created with special parameters. It is a process in which a new mold is born for each object, and hot ore flows in the mold like 1,400 degrees. Here, C.dot code can code the mold, that is the sands, and manage its journey as it turns into a product. Galvanization is a process that starts with the transformation of a steel billet into a billet at 1,300 degrees Celsius, then enters acid pools, then enters galvanizing pools, and after the surface is coated with 80 to 100 microns, C.dot code assigns an identity to the surface at the very beginning, when it is a billet at 1,300 degrees Celsius, and then in all the other steps I have mentioned. That it can be tracked from end to end. Well, what we are saying right now is that for about 4 years before we held the webinar with you today, we have already placed C.dot code on millions of products and we continue to do so. I would like to share with you some examples based on what we have explained, and I would like to share many of the use cases we have created in the world. To go in order, today we are actually talking about a world and an area where production takes place, such as ovens, refrigerators, washing machines, which we call home appliance, which we think of as the white goods sector in our lives. At this point, the example you see on the screen concerns the oven process of a white goods company that we are currently implementing today. What did we mean? Why did they prefer CDOT code? Why did they want CDOT code to be applied? What you see on the screen is an inner body of the oven. This is a part of the oven that is actually placed inside the oven cavity to allow us to cook food at high temperatures. This part has to withstand thousands of degrees. In order to withstand these thousands of degrees, it is actually produced from sheet metal in the first step. These take a form. The sheet now takes the shape of the body. After taking the body shape, it enters the enameling process. When we say enameling process, although it may not be very clear from the picture on the screen, it will actually be better understood from the picture shown by the reader. That sheet metal surface is coated with 120 micron enamel powder, so actually the surface turns into a completely different form. And when we applied this, we used the laser marking technique and wrote CDOT code on the surface in 4 seconds. As you can see on the hangers, the product started to move and came to its first most difficult process. Where was this enamel process? The surface was
Very
enameled.
interesting.
When it comes out, the shape of the code that you see on the screen a little bit, the code is now captured and detected by a camera, as you see on the screen. And even though CDOT code has a coating of this size on the surface, it is 100% readable without losing its identity. And CDOT code can be traced in this process in millions of active production units. So does a furnace body end its journey here? No, it doesn't. That enameled surface continues its journey to another difficult process. This is the process we call the furnacing process. Here, that enamel powdered product, which we have just seen as a grayer, more metallized product, is furnaced at 800 degrees with the enamel powder. When it is fully furnaced, it changes. The effect of furnacing turns into a completely different structural form with the factors added by the enamel dust. The effect on the surface that you have just seen on the screen changes its entire structure structurally and organically after furnacing. At this point, we monitored an oven body furnace for 20 minutes at a surface temperature of 8 degrees after the enameling of the CDOT code, which we had previously assigned while it was still sheet metal, as I mentioned earlier. And now we are currently applying its traceability on millions of products without losing its identity when it comes to the furnacing process. Let's continue a little more. Before we talk about the paint process, before we go to paint, the body of a washing machine, as you can see on the screen, it consists of sheet metal. This sheet is actually formed by the press machine. We write the CDOT code with laser marking in 4 seconds during the forming of the sheet metal. Then there are forming processes and a journey to painting. But before we get to the difficult process of painting, there is a difficult situation in the factory conditions where there are the angle factors I mentioned earlier, distance factors, and this time, due to the nature of the factory, the volume and structure of the product we produce. This time, it's not a process challenge, it's actually a condition challenge. As you can see right here on the screen, in the far right corner, a washing machine moves on a single hanger. 360 degrees around its own axis has risks such as swinging the distance, but because of the risks of the product swinging, you can only get it close to a camera at a distance of 1.5 meters. And because there is a requirement to be able to place the code in the interior, because in order not to affect the cosmetic structure, we are now able to monitor a 20 millimeter by 20 millimeter code in the inner region from 1.5 meters at an angle of 28 degrees with CDOT code without interruption, and we are sending the data we receive from here to the industrial artificial intelligence in the factory. Well, those products that were suspended earlier moved step by step and entered the paint process this time. 220 micron paint was coated on the CDOT code, which we could see in this area when we came back a moment ago. It has now turned into a painted body part of the washing machine. Although 220 micron paint has been applied on this painted part, the CDOT code we placed on that surface in the previous stage can detect it even after the paint is coated, and we are now able to detect and combine it with artificial intelligence by separating the paint values, the contamination rates of the assigned paint, the quality of the micron paint, and the process values that are actually applied on the object, such as the quality of the micron paint, so that we can pass the 100% assigned identity to artificial intelligence and provide a real-time relationship. Now let's go to different areas and different processes. Especially today, there are aluminum products produced by low-pressure die casting in LPDC production. Now, when I say some products, everyone will think of them and empathize a lot. What you see on the screen now is the aluminum housing, where the batteries of an electric vehicle are placed. So how is this product produced? This product you see has a mold. An aluminum, liquid aluminum, is poured into this mold at temperatures of about 300 degrees, between 300 and 350 degrees. After it's poured in, the object first hardens quickly, and the aluminum battery tray that you see on the screen. At this point, when this battery tray is at a temperature of 300 degrees Celsius, the laser marking writes the CDOT code on the surface of the product, as you can see on the screen, in 26 seconds. There is a temperature factor. Please imagine, there is a mold, liquid aluminum flows into it, the roughness of the surface when it flows, factors, all these factors. When we are in the beginning phase, we place CDOT code, and it was able to make the journey of this product traceable from end to end. So what other similar products are produced with low pressure casting? Today, engine blocks, cylinder heads, in fact, all the low pressure casting products that make up the engine area of our car, all the aluminum products, we are now achieving the end-to-end traceability of all aluminum products. So is it over here? Now, as we said, our initial phase, we are able to provide uninterrupted traceability from the very beginning to the very end of the work, and we are associated with the data, because in the first phase, we actually needed casting data. We needed data in productions where the most scrap products are produced, where the most problematic products are encountered, especially in low-pressure casting production. The temperature applied to the mold at the moment of application of the problem, the temperature thresholds of the objects are very critical. These are factors that contain very minimal variations that can cause 50 products to be born faulty out of 100 products. At this point, if we assign the identity while we are still in the casting stage, and if we transform the process that we combine with the identity, we create an item-based monitored process, we can improve and find the root problems. Well, we continued from this step. Steps like forming it, straightening it, and so on. These are areas and processes where the code will not be affected. The next step is much more difficult, and this is a very heavy, bulky object of about 1.5 meters. These can be placed in baskets so that they can be heat treated in bulk. At this point on the screen, what we are actually trying to show you is more difficult. Now, the products will be subjected to a heat treatment of 1,300 degrees. But at the same time, they are placed in a basket that will enable those products to undergo heat treatment. And what needs to be done is both to follow the basket, to ensure the relationship between the basket and the product, and at the same time to continue the journey of the product that will be subjected to heat treatment without being affected by the heat treatment. At this point, the examples on the screen actually show us that CDOT code lives without losing its identity, no matter what conditions happen to it. We can realize traceability without losing the relationship between the basket and the product in all variables, such as the photo of a product surface after heat treatment, rusting after the basket has been in and out of an area of 1,300 degrees many times a day, and the surface reacts to heat. Now, as I mentioned at the beginning, as of this year, in the world today, not only CDOT code's invention, but also an artificial intelligence supported CDOT code, the objects produced over a sand mold in the world are still in the initial stage of the relationship between the mold and the ore. We have come up with another process application invention with CDOT code that can provide end-to-end traceability. As I said earlier, when you look here, we actually see a vehicle disc on the screen. These are especially the discs of heavy vehicles, trucks and vehicles described in this segment. So how are these discs actually produced? They are produced with sand molds. These are specially compressed sand molds with certain alloys, and in these sand molds, 1,400 degrees of ore flows. That ore is passing through the negatively and positively produced molds. After the sand mold, which is produced negatively and positively, combines with the ore, as you can see on the screen, the disc emerges with its final cooling. At this point, we place the CDOT code on the sand mold, as you can see, and then they merged negatively and positively. The challenge is not over. Ore flowed into it. After the ore flowed in, the product cooled down and took its own structural form. As you can see right here, we were able to follow the journey from sand mold to coating on a disc from end to end. What did this bring us? Now I can access the carbon values of this disc. I can get the alloy values of the metal on a disc basis. What does this mean? If you can access the production values of that disc at the time of an accident that may occur today, in real time and individually, you actually start to go to the root cause of the problem. And what do we start to gain when we associate root causes with process data? Artificial intelligence itself, because today we should please see artificial intelligence as a child. To nurture a child's growth and unlock their intelligence, they need to be consistently provided with reliable and accurate data. Here, we are actually saying that if we feed it with the information of any product to be produced that we touch and notice in our lives with the invention of CDOT code, today, artificial intelligence will turn to us and say that if you produce this step in this process with these values, you will increase your production quality and increase your production from end to end. It will be able to produce outputs such as the ability to continue in a quality manner. To make it a little more difficult, I mentioned it at the beginning. In fact, today we have come to the main material of automotive and other sectors, especially the parts to be produced in production, the logs, iron bars, and many other materials that actually form the houses and buildings of all of us in the construction sector. So we are actually talking about the logs from which steel is produced. Today, iron extracted from mines and after the iron ore extracted from the mine is born at a certain temperature in crucibles at thousands of degrees, as you can see on the screen, CDOT code is written on that hot ember log at 700 degrees, and then the first stage of action for this to go to other steps is a temperature of 700 degrees. At this temperature, the object starts to change every second. Think of it like a snake shedding its shell. The surface is so hot that the sector actually describes it as scaling. Until it cools down, it actually starts to shed its shell over the surface without stopping. At this point, as in the examples you see on the screen, we wrote the CDOT code on the product in 15 seconds at a temperature of 700 degrees. The product started to shed its shells, that is scaling, and we are referring to the processes that each sample goes through. When we make the first assignment, we are now providing end-to-end traceability of the logs that give rise to the iron bars that make up our buildings from the very beginning to the iron bars that make up the buildings with the factors created by the roughness effects on the surface, apart from the 2-hour cooling, 2-day cooling. If we have coded the billet I have just given, that is, we have coded the billet at a temperature of 700 degrees, these billets are directed to companies that produce new products from them for other steps. Please imagine we have just coded the log at 700 degrees. The log has gone through a number of steps and gone to another customer, because that customer will take this product, give it a form, put it in acid pools, galvanize it, and it will go to another customer for another step. It will be directing it to the other customers, which will enable it to turn into another product. At this point, even though the product was exposed to acid in the acid pool for about 20 to 30 minutes, after we coated it in the billet stage at the very beginning, which is the sample on the right and the one at the bottom on the right. That sample we saw at the very beginning was now subjected to acid. The surface gave a reaction as if it was half rusting. CDOT code did not lose 100% of its identity despite this acid effect. We didn't finish here, as the products were bulky and tonnage products. These heavy products were immersed in galvanizing pools on hangers. 120 microns of galvanized coating was applied in the galvanizing pools, and after the coating was completed, we actually made CDOT code traceable from end to end.
As I mentioned you at the very beginning, that an object, for example, is actually the shaft pipes under our cars. In order to produce shaft pipes, the sector actually increases the length distance of the object with the process we called cold drawing of a pipe. So you double the first dimension of a pipe, then you treble the original size. By pooling, when we cold drawing, we lengthen the object structurally.
At this point, the example is a very good example. First of all, the first one you see on the left is the size of CDOT code before the drawing operation took place, and the size that we have verified 100%. Then it is doubled. The surface is just like a bending dough. They squeeze and pull the steel pipe, and here we went to the 100% readable stage, even though it was doubled. It came to a final stage, tripled. Just as you can see, the shape of the CDOT code, which started as a square, ended up as a very large rectangle, because the object has tripled in size. At this point, we continued its journey without losing its identity by associating the ID we assigned to CDOT code with all the process data. But it doesn't end with this. After finishing this, it goes into acid dissolution, because these, especially the pipes, as we all know very well, must be able to withstand the weather conditions, and all the things that cars actually experience. At this point, after entering the acid process, we have actually made the pipe that will be finished and will now be attached to a car, traceable from the very beginning to the very end without losing its identity. Let's go to more familiar examples now. Here we come to the automotive industry. In fact, heat treatment is one of the most difficult processes that the automotive industry is most interested in. Another difficult product is a brake part, but this brake part is born as steel and zinc is coated on it. We said at the beginning that we cannot put a label on such a part. If we use any other code and it is zinc plated, we cannot trace it because it is zinc plated. But this is a brake part, a brake drum. It is the most important safety part. If we cannot detect any problems that may occur here, it is actually an accident that a car has. We hear it very well in the industry today. Automotive companies collect vehicles. They make recalls. In fact, the main reasons for this are that they are hardly getting to the very root cause. To determine where the real problematic problem is, they do recalls in order to reduce their risks. At this point, CDOT code, heat treatment, zinc coating, 350 micron paint coatings, such as the wheels you see on the screen, live and follow the product without losing it. We have differentiated it a little more, not only coatings, heat treatments, but also car tire. When we transfer CDOT code to the tire surface, as you can see on the screen now, we now have CDOT code on the surface of this tire. What has this started to bring us? When we try to change car tires in winter, which we all know, we have a measurement problem. So, if I can get in touch with the object, that is, if I can make the tire of my car communicate with me when I hold a camera to the tire of my car as a person on the street with the information assigned to that object by the manufacturer who produced the object, we will actually lead to solving many of our problems that we ignore today. Today, with CDOT code, we can access when we need to change the tire, how far it has traveled, and many other information from the camera we point at the tire. Finally, the plates and porcelain objects in our lives, as I said earlier, we can observe every object, every element, every material in the world, despite all its difficulties. Today, porcelain plates are actually born from sand and mud. When they are in the mud and sand stage, CDOT code is transferred onto the surface, and then there is a glazing process called glazing, which is the dipping technique of those sand plates, that is, plates made of mud, and the glossy porcelain effect that we feel today. But the surface is both coated and wrapped with a very special alloy. At this point, we are now able to make a unique assignment without losing its identity when the plate born from clay is coated and enters the porcelain stage and comes to our homes. What does this give us? We can now interact with the plate. We can establish a connection between the plate manufacturer, the chef who serves the plate, the information he wants to transfer to his plate, and the user. Yes, these may seem a bit strange to us today, but today the relationship between artificial intelligence and objects is becoming more and more necessary. If we can establish a connection between objects and artificial intelligence, we are actually starting to use artificial intelligence comfortably. The artificial intelligence that is in our lives today, we are talking about an artificial intelligence that is born with data fed from the digital world and that tries to complete its own learning and education in the digital world. Let's imagine this now. When you visualize CDOT code as a bridge that can connect artificial intelligence with the objects that we actually touch in our lives, that we describe in the analog circle, when I connect with the object with a simple camera, it is actually talking to the object, artificial intelligence, through the camera, or communicating, getting information, looking for solutions to our problems or the benefits it can provide, the information that the manufacturer assigns to the object and the connection that the end user establishes with this object. We can think of it as including artificial intelligence in interactive information. So what have these achievements revealed? As I have just underlined, we provide the 4 zeros of traceability. We create a truly digital factory. We really create data for the artificial intelligence of the industry. If you start to make an object traceable from the very beginning to the very end of an object today, you will achieve the following gain very simply. How much product do I have before and after each process in your factory? How much product have I produced? Accessing the information in real time means that in real time, it actually eliminates the time that factories stop for counting today, the time that the industry loses at that moment. On the other hand, if I can track and record each process step in real time with its real data when it passes from process A to process B, from B to C, I can intervene on a product basis, that is, not on a batch basis, prevent before the problematic, for example, scrap product or low quality product, leaves the factory before the second or third step detects the problem before completing the other steps. Intervene on the basis of the problematic product and ensure that only my problem-free, high-quality products, which I will produce and ship, leave the door. And these, of course, can naturally lead to an increase in our quality, and based on quality, increase our production quality and production speed to such an extent that the problems between the customer and the producer can be reduced to zero level. Let me thank you. I tried to explain as much and as quickly as I could.
I didn't want to interrupt. First of all, I'm not happy with my voice anyway, so that I don't disturb people too much. Secondly, you are going very well. There are questions. I'm following the questions. Thank you. It's really the embodiment of a very, very successful technology. A good example. Through Cozumpark's portal, I am sharing what is happening with us live on this platform and what will happen next on our YouTube channel with the recording, of course. Look, it is very pleasing because, as they say, the product works. There is such a situation. This is what's happening with the CDOT code. We're going to talk about it until the morning. We're going to lie on our side. At the end of the day, they say, let's see the product, especially your live working applications in the factories of manufacturers are very important. Many of the questions are already answered, but now let's answer the questions. Let's take a look. Mr. Omer's first question, when the glass is painted, but can the system still read this code? You already answered that.
It can.
You said it, yes, definitely. I'll continue. Mr. Taha's question, does every time you paint or heat and expand, is your identity damaged? Mr. Taha, no, he probably means, is it damaged?
It's not.
None, no harm. Mr. Omer's question is, does the system only work on-prem? Is there a cloud service? What should be the minimum camera resolution?
That's a good question. It works on-prem. It also works in the cloud. In fact, it is now being adapted in the edge devices so that CDOT is decoded. I'm proud to say that the minimum camera capability, there are no more cameras below 1 megapixel, but I would say below 1 megapixel is actually capable of transfer to verify CDOT code. So we don't need high resolution. In the industry today, they can hardly use a 1 megapixel camera anymore because of these problems we are talking about. For us, a maximum of 1 megapixel camera is enough.
Okay, great. 1 megapixel and below megapixels.
Yes, because we need 200 pixels. A resolution of 200 pixels is actually enough for us. But there is no such camera in the field right now that takes a picture with that resolution. Yes, it is. That's why I always say that our maximum level is 1 megapixel camera.
The rest is not very important.
Yes, not really, indeed.
Mr. Ali's question is, can we learn how this solution can be integrated into existing laser marking devices and readers?
Mr. Ali,
Will any hardware changes need to be made in the enterprises for this integration?
At the very beginning, maybe I went through it a bit fast. We don't need any special laser machines for the implementation of CDOT code. They can easily print CDOT code with the laser machines they already have or on all the laser machines they will buy. Because today laser marking machines actually print codes in certain file formats. CDOT code is compatible with all file formats in the world, and as a result, it can be marked with all laser marking devices. They do not need to create a special external, separate equipment or a new technical infrastructure for this. CDOT code can be adapted within the control panels that enable them to mark with laser, and they can easily mark in any file format they want.
That's great. This is very important for integration. I mean, they can do POC instantly, very quickly.
On the same day?
That's great. If I want to do POC, do you have to come or can I do it? Actually, no.
Actually, no. Now we are going to launch it through our portal very soon. They can download the sample CDOT code through our portal. When they download it, it will be enough for them to read their own application instructions. They will print it and download our Decoder mobile app from the stores, print it on the product, and put it into their processes. Afterwards, they will be able to read it on our mobile app and apply it themselves easily. But we are pleased to say that, especially since the sector and industry in question are difficult conditions, we also realize all of the request demos that are requested in this regard by going to the field. And in order to realize it, we can quickly provide them with all their preparations.
Okay, super. Mr. Selim's question, can it be applied on rubber products? Last time you told about tires, etc. Can it already be applied?
Since there are many examples we have actually shared today, especially car cooling pipes consist of rubber materials. They are subject to 200-degree temperatures. Rubber material, I can say all materials described as soft or hard PP. Regardless of CDOT code, these materials can be curved surfaces, not flat surfaces, on all kinds of materials that exist in the world, regardless of CDOT code. It can be applied on all kinds of materials and surfaces.
Super. I apologize for Mr. Sina's question. Maybe it was mentioned, I missed it, and I listened to it with great pleasure. But what is the technology behind it? How can code withstand so much degradation and still make sense? What is its hallmark?
Thank you very much for the question. CDOT is a code with a matrix in a special sequence that can transfer data to industrial artificial intelligence applications, enabling transportation and identification on the product without losing the data in difficult conditions. Today, CDOT is a code developed with signal science and stenography, inventors me and my team, and made available to the world by CosmoDot. the technology behind it. It is a novel signal and stenography algorithm which allows for robust and resistant 2D identification code system. This is actually a science of signaling.
It's not just taking a picture, so let's look at it that way. You already understood from the code, friends, it is not a very simple code. Back to the beginning. Good questions, yes, very good questions. Do you also do the printing of this code?
No, actually, our main responsibility is that we are a developer software R&D company. At this point, the printing of the codes, the printing operations of the codes in the field, we already have partners. We have hardware partners, or you may have your own hardwares. As I just mentioned, we are already providing quick training and adaptation of the steps that will ensure its adaptation, that is printing or marking. If there is no hardware, we direct our relevant hardware partners. They can quickly mark them with the laser marking devices they have supplied.
How does the process start when you want to use CDOT code?
When we want to use it, there are actually two main critical points for us. They are actually pre-analysis questions. As I just said, do you have lasers to print? After receiving some information, such as how many cameras you have in your field, we determine the total number of lasers they need. Since they are members of the system with that total number of lasers, they can instantly access this package. And then, as I just explained, since they don't need a special camera and so on, they have two components. One is the CDOT codes and the decode of CDOT, which we describe as a decoder. They can install their systems by downloading all of these from the existing portal. This is the first method. Secondly, we have field teams. With our teams, adaptation to the factory is done instantly within a maximum period of 2 days. I hope I gave the answer.
Thank you, brother. Our last question is again, Mr. Tahas. Which algorithm do you use in the artificial intelligence part of the product?
In fact, we can have many different approaches in artificial intelligence. Especially today, there is talk about a generative artificial intelligence. Today, like Google's Gemini, AWS actually has a lot of artificial intelligence modeling and is generating and extending it. The main point that we undertake is that we are an AI-compatible code. This also means this. We are not actually using an AI technology. We're not using an AI. We pass data to AI in real time that it can use in its models. In this context, we are not actually code-born with an AI model. We are a code that acts as a real-time bridge that can transfer the data needed by all existing artificial intelligence models that can exist in the world. So in this sense, there is no artificial intelligence technology behind it, to be more specific.
Thank you, brother. We answered all the questions. I think it was a very successful webinar to raise awareness also. And thank you very much to everyone who asked questions. You actually approached it with your head. I felt very happy when the questions were very similar. They tell me too, I pull it, I bend it, I bend it, I bend it, and so on. Mr. Taha, Mr. Umar, Mr. Ali. I may not have been able to read everyone's names. I was happy when their questions were like mine. I said, I guess there is a way of reasoning. You have answers to all of them. Hopefully after this webinar, CDOT codes will be used as a solution to the problems of related industries and producers in the world. That they have heard and learned to be able to contribute to such a successful industry standard. We are also proud to ensure such a successful industry standard. That's a good sentence. I think the technology is very successful, very useful, and very good. I wish you success on this path. I would like to thank everyone who contributed. I would also like to thank those who participated. I will just leave the last word to you for closing.
First of all, I would like to thank you, Hakan, on behalf of all participants for this webcast. I would like to thank you very much. We are working very seriously with our teams and consultants to ensure that CDOT codes take an important position in the industry, just like the other codes in the world. Such webcasts are very valuable for us. I would like to thank each and every participant individually, and I would also like to thank you for the questions and the style of the questions. I can't think of anything else right now.
We've already had you talking for an hour. Thank you. Thank you very much.
And last but not least, I have to add, in fact, our AWS partner, Reddington, who brought us together with you, Hakan, has actually been a very important occasion for us to meet you today and for you to get to know us. At this point, I would like to thank them for all their contributions and support.
Of course, you're right about the organization. We have Reddington, who brought us together, is also your authorized distributor here, isn't it?
Yes, Reddington is one of the main distributors of Amazon Web Services, and together we are in their network as we
a
are managing cloud
distributor, let's
operations.
say they are the architects of the organization. I would also like to thank them. And thank you very much to everyone. I'm a bit sick, sorry, I'm very active like this.
Again, take care to yourself, and I wish you a speedy recovery.
I didn't
You are
have to
always on the
go in
screens.
and
Yes, I
throw
hope you
my
have a speedy
shoulder in
recovery.
when the stuff was nuts. Let's say you entered, you explained, you finished. Hope to see you at the next webinar. I say goodbye to everyone. Have a good day, friends.